Hello everyone, today I will explain my homework 4.4 exercise 3.6. Write a CH to control C++ language by control GPS sensor. Let's focus on homework content directly. This slide shows the crucial goals of the assignment. There are three main goals. Achieve communication between Arduino written in C++ and the GPS sensor to get data like satellite count, latitude, longitude, speed, and altitude. Use a WinForm program write in CH to build sensor communication with Arduino, review and show GPS date. Third, understand the cross-language hardware communication logical. The host computer CH controls the slave computer Arduino. This slide lists all the hardware needed for this assignment. Arduino Uno development board, LED light, jumper wheels, breadboard, and the wheelchair LC76G GNSS GPS model. These hardware are the basis of the whole system. Now is missing. Then the connection method. GPS VCC connection to Arduino's 5V. GPS ground connects to Arduino's ground. GPS TX connects to Arduino's pin D4. RX connects to Arduino's pin D3. Now the hardware is connected. This is the C++ code for Arduino. Its job is to communication with the GPS sensor, parse date, and send it to the CH program. First, we need to add two libraries. Tiner GPS C++.h used to parse the GPS single date. Software serial.h used to create a software serial port. Because Arduino's hardware serial port connects to the computer, we use software serial port to connect to the GPS. Create a software serial object set pin. This slide is explain setup and log function. In the setup function, start the serial port for computer. Communication baud rate 9600 starts the software serial port for GPS. Communication baud rate 115200 match the GPS. In the log function, keep reading and parsing GPS date when the date is updated. Output satellite count, latitude, longitude, and other in off, and adding at last, so CH knows this is a complete set of date. The core of CH program is the receive date and the display date. This slide is the basic preparation interface components. Component box 1. Display available serial ports for selecting the one connected to Arduino. Button 1. Control serial port. Connect or disconnect. List box 1. Display received GPS date in real time. This is C hash code. This using code to import toolkits that helps the program do different tasks. The K1 is in line 8. Using system I/O point ports. It's a necessary toolkit for several communication. Without it, the program can't set date with Arduino via several ports. Form 1. Internalize window controls and let actions like window loading. Button clicking trigger related function. Form 1 load. Get several ports of the computer. Show port name in the drop-down box, common box to choose. Arduino's port. Enable the button if there are ports, or show no serial port if not. This is the click function of the connect button. If the serial port is not open, set the port name choose from the drop-down box. Boundary 9600. Match Arduino. Open the port and start the timer. If the port is open, close the port and stop the timer. If there's a connection error, a message box pops up to explain the error. Function. Switch between connecting or disconnecting the several ports. Read date from the serial port until it gets ending. The end mark set by Arduino. Save the date to GPS1, then clear all date in the serial port. If there's a reading error, like pulling out the USB cable, the program ignores the error and won't crash. There is a function of the timer runs regularly. If there's date in GPS1 and the date to list box, the display box let the display box scrolls to the latest date automatically. Then clear GPS1 to prepare for new date. This is memory. Several communication learned how to use Arduino's hardware or software serial port, and how to configure serial port and set or receive date in C#. 2. GPS date parsing. Learned to use the Tina GPS++ library to get useful info from the GPS. 3. Cross language devices. Know the jobs of C# host computer and C++ Arduino. 4. Hardware connection. Learn the power requirements of different models and how to match pins to avoid breaking hardware. Now I have connected to the hardware as shown in PPT. Let's look at GPS connects to Arduino. Arduino connects to the computer via USB. The C++ code has also been uploaded to Arduino. Now open the C# program, choose the right serial port and click Connect. Because the GPS needs an open place to locate. I put the device by the window in a device to receive satellite signals. Now we can see this is C# code. Now we can see the real-time date in the C# program's list box. Satellite count, latitude, longitude, speed, and altitude are updated normally. It means the whole system works well. That's all of my assignment explanation. From hardware code to knowledge points and demonstration, I have achieved the requirement of using C# to control C++ by controlling a GPS sensor. Thanks for your listening. Goodbye.